Section 3.2 Box Plots. Here's an example of a box plot. You need to know all the key features of a box plot. So make sure you're labeling these in your notes as well. I'm going to start right in the middle, and the middle is the median. So here we have the median, the vertical line in the middle of the box. Well, not right in the middle, I mean inside the box. It could be, and often is, closer to one of the two sides. That's the median. Either side of that we have the lower quartile and the upper quartile. So the line inside the box is the median, and then the edges of the two of the box are the lower quartile and upper quartile. Going to the far right hand side now, this value on the far right hand side, it's either the highest value in the data or it's the boundary for outliers. It could be one of those two things. Same at the lower end. This one here is either the lowest value in the data, or it could be the boundary for outliers at the lower end. And this X, which is separate from the rest of the box plot, that is an outlier. That has been calculated to be unusually low. Doesn't mean we're going to get rid of it though. We still keep that data unless we know it was definitely from an error. Another key characteristic of a box plot is that it divides the data up into quarters. So if I just draw some lines, I recommend you do the same in your notes as well. So from the very, very smallest value, which is the outlier in this case, up to the lower quartile, then the median, then the upper quartile, and then the highest value here, we have 25% of the data in each of those four quarters. In some sections it's more spread out than others, but 25% of the data will be in each of those four sections. Really important point. So when you're comparing data, you should compare a measure of location, that's either the median, which we can tell from a box plot, or the mean, which we can't get from a box plot, but you might have calculated that already. So when comparing two sets of data, compare a measure of location and also compare a measure of spread. We can get the interquartile range from the box plot, upper quartile, take away lower quartile, but we can't get the standard deviation from a box plot. Again, you might have already calculated that earlier in the question on a separate part. Remember, the interquartile range looks at the middle 50% of the data, and this box plot helps us to identify the middle 50% really well. Okay, next up, interpreting skew. Skew is a way of describing the shape that the distribution of data makes when it is displayed in a histogram or a box plot or a stem and leaf diagram or any other statistical diagram. The shape of the graph depends on the distribution of the data, and when data fits the following criteria, it is said to be positively or negatively skewed, or it's symmetrical. If it's symmetrical, then we say it has no skew. Don't say it is symmetrically skewed, because that doesn't make sense. I'm just going to add that into your notes. I recommend you do the same. So don't say symmetrically skewed, because that doesn't make any sense. If it's symmetric, then it doesn't have any skew. So the three situations are, if we have positive skew, looking at the box plot, you can see, if you remember, data in a box plot is divided up into quarters, 25%. Between the lower quartile on this diagram and the median, it's very, very condensed. There's still 25% of the data from the whole data set between the lower quartile and the median, but they're very close together. So there's a lot of data clustered around this lower quartile and median. If we notice that, then we say this is positive skew. The calculations we can use to show that, if the distance between the upper quartile and if the median and the lower quartile, so Q2 take away Q1, is less than the distance between the upper quartile and the median. So going back to this diagram, the distance between Q2 and Q1 is this bit here. If that is smaller than the distance between the median and the upper quartile, then we call that positive skew. You will just need to remember, if a graph looks like things are pushed towards the left hand side, so more data is on the left hand side of the box, then that represents positive skew, and the opposite to that, if everything's pushed towards the right, that's negative skew. So in the second case, negative skew, lots of data up towards the top end. So Q2 take Q1, which is this distance here. If that's bigger than Q3 take away Q2, which is that distance there, then we have negative skew. And if it's symmetric, then the distance between the lower quartile and the median will be the same as the distance between the median and the upper quartile. So symmetric, meaning it doesn't have any skew. If the numbers we're working with are the mode and the median and the mean, rather than the quartiles in a box plot, then these are the three rules that we would use here. Of course, the easy one, mode and median and mean, all the same, means the data is symmetric. But towards the other end, these you need to become familiar with these. Now we don't often have the mode, so we might not have that. We might just have the other two. If the median is lower than the mean, then it's positively skewed. Again, the second one, you don't often have the mode. So if the median is greater than the mean, then that's negatively skewed. Of course, the mode could be there as well. I'm just pointing out that you don't often have it. You don't have to have it to conclude that the data is skewed. Now remember that each section represents 25%. So if the spread from the median to the upper quartile is smaller than the median to the lower quartile, then the data is closer together in that region. So push to the left, positive skew, push to the right, negative skew. If it's symmetric, then it doesn't have any skew.